Hi my dear children, in today's class I am going to discuss about the Bohr's model of hydrogen atom. When we start about the concept of Bohr's model of hydrogen atom, it is important to emphasize on the limitations of Rutherford's atom model. Limitations. The first limitation of Rutherford's atom model, as you all know, it failed to explain the stability of an atom. It failed to explain the stability of an atom. How it was a failure in explaining the stability of an atom? As you know. So this is a nucleus. Electrons are revolving around, or electron, in case of a hydrogen atom, electron is revolving around the nucleus. When electrons are revolving around the nucleus, it experiences what is called a centripetal acceleration. That means this electron is now an accelerated charge. This electron is now an accelerated charge according to Maxwell's hypothesis. Accelerated charge will radiate energy. Accelerated charge will radiate energy, right? The source of electromagnetic radiations are accelerated charges. So accelerated charges will radiate its energy, and gradually what will happen? As it radiates energy, the size of the orbit should reduce and finally it will fall into the nucleus by following a spiral path. So when electrons fall into the nucleus, how can we account for the stability? That means atom cannot remain stable thereafter. So let me tell you one of the important limitations of the Rutherford's atom model. Limitations of Rutherford's atom model. Model is, it failed to explain the stability of an atom. That is first point. Then second point I have to say is that it failed to explain the spectrum of hydrogen. It failed to explain the spectrum, as you know. It failed to explain the spectrum of hydrogen. Spectrum of hydrogen. It failed to explain the spectrum of hydrogen. Lyman series, Balmer series, Paschen series, bracket series, Fun series. Likewise, there are spectral series for hydrogen atoms. So it failed to explain the spectrum of hydrogen. So these are the two limitations of Rutherford's atom model. And so what I will say is that Bohr's model of atom was a model designed to correct the limitations of Rutherford's atom model. The first and most important thing I want to tell you regarding Bohr's model atom is, it is a semi-classical model of an atom. Semi-classical model. Bohr's model is a semi-classical model of an atom. Why did I say it's a semi-classical model? Because it used the existing quantum theory. The quantum theory of that time also was used to explain this model. That is, E is equal to h nu. Energy is equal to h nu was known by that time. So it is a semi-classical model of an atom. So Bohr's model of hydrogen atom is a semi-classical model of an atom. In the sense semi-classical because it used the existing quantum theory along with the classical theory. Thomson's model as well as Rutherford's atom models were using classical theory. Thomson's model and Rutherford's model. I am not sure whether I made a mistake while saying. Thomson's model and Rutherford's model used was based on the classical theory, that is based on classical mechanics, And so actually when it comes to Bohr's model of atom, it used classical wave theory along with the quantum theory to explain the model. So let us come to the basic points. So one of the problems related to Rutherford's atom model was that electrons were spiraling, right? To contradict for that or to solve that issue, he introduced the concept of what is called as stationary orbits. The first and most important postulate of the Bohr atom model is the concept of stationary orbits were introduced. What do you mean by stationary orbit? What do you mean by stationary orbit? I'm sorry. Stationary orbits. So electrons are confined to move around the nucleus in fixed path. I repeat. Electrons are confined to move around the nucleus in fixed circular paths called stationary orbits or circular paths of fixed energy. Electrons, that is what is stationary orbit. Electrons are made to move around nucleus in circular paths of fixed energy. Circular paths of fixed energy, and that orbits are called stationary orbits. So electrons will move around the nucleus with fixed energy in circular orbits called stationary orbits. That is point number 1. So in point number 2, point number 2 is regarding the angular momentum. Angular momentum. So angular momentum. So what type of stationary orbits are possible? Let me tell you, only those stationary orbits are allowed whose angular momentum is an integral multiple of nh by 2 pi. Only those stationary orbits are allowed whose angular momentum is an integral multiple of h by 2 pi. That is second postulate of Niels Bohr. Only those stationary orbits are permitted whose angular momentum is an integral multiple of h by 2 pi. h by 2 pi. That is second postulate. Now coming on to the third postulate is regarding the discrete energy levels, or what I'm saying, to explain the spectrum. So that is where we say what I'm saying. So absorption spectra and emission spectra. I'm not writing that point separately. These are the two important points here to say. One is stationary orbit, the one that is electrons are confined to revolve around the nucleus in fixed circular paths called circular paths of fixed energy. And only those stationary orbits are possible whose angular momentum is an integral multiple of h by 2 pi. Now regarding the spectrum. So third point is regarding the spectrum. That is, when an electron makes a transition from one orbit to another orbit, when an electron makes a transition from one orbit to another orbit, energy exchange occurs. Energy exchange occurs when it makes a transition from one energy level to another orbit, one orbit to another orbit. Energy exchange occurs. If an electron makes a transition from a lower energy level to higher energy level, that results in the absorption of energy that will lead to what is called absorption spectra. I repeat, when an electron makes a transition from a lower orbit to higher orbit, absorption of energy occurs and that leads to what is called absorption spectra. Similarly, when the electron makes a transition from a higher energy level to lower energy level or higher orbit to lower orbit, what happens? It will release energy and that will lead to what is called the emission spectra. That will lead to emission spectra. So two types of spectra are there. The first one is called the absorption spectra. Second one is called the emission spectra. Absorption spectra comes when it makes a transition from a lower orbit to higher orbit. Emission spectra comes into play when an electron makes a transition from higher orbit to lower orbit. Now we will explain the mechanism of Bohr's model. We have to find out the velocity of the nth orbit, radius of the nth orbit, all such things. So for that, let me tell you the whole theory of Bohr's model of atom lies in two equations. The first equation, for the orbiting electron, the required centripetal force is given by the electrostatic force of attraction between the electron and the nucleus. Now we are considering for hydrogen atom, so Z is equal to 1. mvn square divided by Rn is equal to k E square divided by Rn square. So what I can do? So this is first equation. From here we will get mvn square Rn is equal to k E square. That is equation number 1 for us. Now second one. So this is based on the first postulate. The postulate of stationary orbit. Electrons are revolving around the nucleus in circular orbits. So when a body moves in a circular orbit, there should be a centripetal force, and that centripetal force is provided by the electrostatic force of attraction between the electron and the nucleus. This is first equation, first postulate. Coming on to the second postulate is regarding the angular momentum. So we know that angular momentum L is equal to m into Vn into Rn. That is equal to nh divided by 2 pi. That is equation number 2. Yes. Now I tell you these two equations are very important. I just wrote it with a green color only because they are very important equations. So coming on to the simplification. What will be equation 1 divided by equation 2 is? Equation 1 divided by equation 2 gives, left side we got m and m will cancel, dividing, right, this divided by this, m by m gone, Rn by Rn, that also is gone. So Vn square by Vn, that is Vn is equal to, right side, 2 pi k E square divided by h multiplied by 1 by n. Is it okay? So this dividing this, k E square divided by nh by 2 pi is 2 pi k E square divided by h into 1 by n. You can verify this answer. But what is k is equal to? So this is the equation for velocity of electron in the nth orbit. Okay, so coming on to the next point. So but k is equal to 1 by 4 pi epsilon 0, right? Which implies 2 pi k is equal to 1 by 2 epsilon 0. Right? Check it. Bring this side, you will get this answer. So we will conclude the value of the velocity of the electron in the nth orbit as, okay, I got this one expression, 2 pi k E square divided by h into 1 by n. That is also equal to 2 pi k is 1 by 2 epsilon 0 E square divided by 2 epsilon 0 h into 1 by n. Now E is the charge of the electron, epsilon 0 permitted to free space. You can simplify this to get the answers. 2.2 into 10 to the power 6 divided by n. That much meter per second. We got it this answer yesterday with an example, right? So this is the expression for the velocity of electron in the nth orbit. So remember this equation. So when it comes to ground state, n is equal to 1. So we can say the velocity is equal to 2.2 into 10 to the power 6 divided by 1. So velocity of hydrogen atom, velocity of electron in the ground state orbit of the hydrogen atom is 2.2 into 10 to the power 6 meter per second. Now the velocity of nth orbit we got. Now substituting, let me take this as equation number 3. Equation number 3. Substituting. Now what we will do? Equation 3 I am going to substitute in equation 2 gives. Okay, let us use this equation. m into Vn is equal to this value, 2 pi Ke square divided by Nh into Rn is equal to Nh divided by 2 pi. Right? Now we will rearrange to find the value of Rn. That gives you Rn is equal to, this Nh will go to the numerator, so h square n square. H square n square divided by, this mass will come, okay, 2 pi into 2 pi is 4 pi square. This will come to the denominator. Then Ke square will come to the denominator. M also will come to the denominator. So let me tell you, this is the expression for the radius of electron in the nth orbit. Radius of electron in the nth orbit is n square h square divided by 4 pi square Ke square into m. That is radius of electron in the nth orbit. Okay, now we will simplify again. What is K is equal to 1 by 4 pi epsilon 0. So I was saying Rn is equal to h square divided by m e square, that is there, into 4 pi square into K is 1 by 4 pi epsilon 0. So this 4 pi gone. So what will be the answer for this one? That gives 4 pi is gone. There is 1 pi remaining. Epsilon 0 will go to the numerator. So we will say this answer is going to be something like, okay, I'm just wiping off. I'm taking this epsilon 0 to the numerator. Epsilon 0 will go to the numerator. Then this 4 is gone. There is one more n square coming here. And a pi remains, right? Epsilon 0 h square pi m, epsilon 0 h square divided by pi m square, that multiplied by n square. That's the radius. So we got two equations here. Rn is epsilon 0 h square n square divided by pi m square, that is equal to h square divided by 4 pi m Ke square into n square. And this can be calculated to this. The first part of this equation is a constant, so here also is a constant. This is 0.53 n square angstrom. So 0.53 or 0.529. That's a value you have to understand for the radius. Now, what will be the radius of ground state electron of the hydrogen atom if I ask you the question? Answer is 0.53 angstrom. So n is the energy level number, principal quantum number you used to say when it comes to quantum mechanics. Now we have to get the expression for kinetic energy. Kinetic energy of the electron in the nth orbit is half m v n square, right? Half m v n square, Vn is already we got. So this is equal to, we will substitute this value of Vn. E square, so we will take the square of this, that is e raised to 4, square of e square, because Vn square we want, right? So e square is e raised to 4. Okay, so 1/2 is there. M I will take m e raised to 4. M e raised to 4 divided by 2 square, 4. 4 into 2 is 8. M is from here, e square, the whole square is e raised to 4. Now epsilon 0 square is, epsilon 0 square, h square, that multiplied by 1 by n square, I can say. 1 by n square. What is m here? Mass of the electron. E, charge on the electron, epsilon 0 h and all you know already. Now the term in the first bracket is a constant. This can be equated to 13.6 divided by n square electron volt. The kinetic energy of electron in the nth orbit is 13.6 divided by n square electron volt. That will be our answer to kinetic energy of electron in the nth orbit. Now coming on to the potential energy of electron in the nth orbit. That is equal to minus k E square divided by Rn, right? Now if you look at this one, there is an expression here. If you look at the first equation, from here you got mvn square is equal to ke square divided by Rn, right? Because this Rn is gone, Rn can be cancelled. So mvn square is equal to ke square divided by Rn, right? So I can say this term is nothing but minus 2 times kinetic energy. mvn square is 2k, right? Kinetic energy is half mvn square, which means mvn square is 2kn. The potential energy of electron in the nth orbit is minus 2kn. So I can say this is equal to, so 2kn. m e raised to 4 divided by 4 epsilon 0 square h square. Kinetic energy double. Double the kinetic energy means you have to multiply with the 2. 2 by 8 is 1 by 4. Into 1 by n square. That is equal to minus 27. Okay, one more minus here. Minus 27.2 divided by n square electron volt. That is potential energy of electron in the nth orbit, right? Potential energy of electron in the nth orbit is given by this value. What else? What next? Total energy. I'm just swiping off here. Total energy of electron in the nth orbit. What you can say total energy? Total energy of electron in the nth orbit is the sum of kinetic energy of electron in the nth orbit plus potential energy of electron in the nth orbit. Now we can see that it is equal to minus kinetic energy of electron in the nth orbit, which is equal to, you can see kinetic energy, minus m a raised to 4 divided by 8 epsilon 0 square h square n square. That is minus 13.6 divided by n square electron volt, your answer, right? So that is the end of the discussion on the basic ideas of what I'm saying. The velocity of nth orbit, kinetic radius of the nth orbit. So we will just conclude now by stating these values once more. So we got the answers now. So what is the velocity of electron in the nth orbit? 2 pi k e square divided by h into 1 by n. That is equal to e square divided by 2 epsilon 0 h into n. Now we can see this value is equal to, if this value is equal to 2.2 into 10 to the power 6 divided by n, that much meter per second, right? That is velocity of electron in the nth orbit. Yes, now coming on to the next study, that is regarding the radius of electron in the nth orbit. So from the first equation it is clear that the velocity in the nth orbit is directly proportional to 1 by n. Right? That is first case. Now coming on to the second case, the radius of the nth orbit you can see here, epsilon 0 h square n square divided by pi m e square into n. Okay, sorry, n square is already taken. This is equal to h square divided by 4 pi m k square into n square. This is equal to 0.53 n square angstrom. That itself says the radius of the nth orbit is directly proportional to n square, right? Now the third one I am saying is kinetic energy in the nth orbit. Study this equation alone because everything else can be done by yourself. m e raised to 4 divided by 8 epsilon 0 square h square into n square. That is equal to 13.6 divided by n square electron volt, which implies kinetic energy in the nth orbit is directly proportional to 1 by n square. Now I will insist you to study this much only because The rest, if you want to write potential energy and total energy, you can write just from the kinetic energy itself. How? Potential energy of the electron in the nth orbit is minus 2 times kinetic energy in the nth orbit, and total energy in the nth orbit is equal to minus kinetic energy of the nth orbit. So this is proportional to 1 by n square. This is also proportional to 1 by n square. And so that is all about the basic ideas of Bohr postulate. Basic ideas of Bohr postulate. Now I want you to do some things like, okay, so find out the relation between, okay, time period is proportional to, okay, that's what I'm saying, better than this one, I can say. First conclusion, time period is proportional to n cube if I say agree or disagree. You can see how we get. Time period is equal to 2 pi r by v. So r proportional to n square, right? T proportional to r divided by v, that is proportional to r divided by, n square divided by 1 by n, right? R is proportional to n square, v proportional to 1 by n, so T proportional to n cube. Or this leads to simply the Kepler's condition, r raised to 3 by 2. Right, r proportional to n square. N square the whole raised to 3 by 2 is n cube. That is first thing. Then, frequency directly proportional to n raised to minus 3. Then, electric current I is equal to EF. Proportional to, this n raised to 3. N raised to minus, frequency proportional to n raised to minus 3. Electric current proportional to n raised to minus 3. Right? Then magnetic field at the center, B proportional to I by R is our knowledge, right? I proportional to n raised to minus 3, R proportional to n square, this will be proportional to n raised to minus 5. Then another thing I can say is that magnetic flux, that is B into A, proportional to n raised to minus 5, area proportional to R square, that is n raised to 4, which implies 5 proportional to n raised to minus 1. Magnetic flux proportional to n raised to minus 1. These are a few ideas which you need to remember as a part of the Bohr hypothesis. In the next video, we are going to discuss about energy levels and the spectral series of hydrogen atom. Hope you understand today's discussion. Thank you.